We're going to talk about drawing wiring plans, but before we do that, let's talk about what we know about the nature of electricity. And the whole world, matter and universe, is all made of electricity. And as you probably know, all matter is made of atoms, which consist of what we think of as these elements, these three elements. In the nucleus, in the middle of an atom, are protons and neutrons, and then orbiting around the nucleus are electrons. And we call protons positive charge, and we call electrons negative charge. We could call them something else. They're not really positive and negative, but they are opposite charges, and that's what holds electrons in towards the center of the atom. If you wanted to build a scale model of an atom, let's say a hydrogen atom, it has one proton and one electron, so that would be the simplest model to build. And if you built it to scale, you could use a marble to represent the nucleus of the atom. So here's a marble down in the middle of a football field. So let's say this is Autzen Stadium. And here's a marble. That's our scale model of the nucleus. The electron would be the size of a pinhead, and you would have to put it out at the far outside of the edge of the stadium, orbiting around. That's how much void there is in matter. Marble in the middle, electron out here. The volume of an atom is 1,000,000 billion times as big as the volume of the nucleus. So we think that matter is solid, but in fact it's almost completely void, and the whole universe is held together by these electrical charges. Isn't that amazing? And these electrons, these little bits of electrical charges, are whizzing around the outside of each nucleus, and it's that electrical attraction that holds them in. And they're whizzing so fast that we think of them as forming shells around the outside of the nucleus. And each shell has only so much capacity, so much size. When the shell is full, any additional electrons have to go out to the next shell, and so on and so forth. Here's a diagram of a copper atom. It happens to have 29 protons and 29 neutrons, and all the three inner shells are full. The fourth shell has the one remaining electron in it, and you can see that it's farther away from the nucleus than the other electrons. That outer shell is called a valence shell, and that electron out there whizzing around in that outer shell is called a valence electron. And that's what's important in electricity. As you can think about this electrical attraction here, the farther away from the center that electron is, the less electrical attraction there is, the easier it is to knock that electron loose. And that's what electrical current is, those loose electrons out there in the valence shell getting knocked loose and traveling along until they come to another atom. And they can get loose because they're out there in the valence shell far away from the nucleus. It doesn't take that much energy to knock them loose. So now let's think about the words that we use when we talk about this happening. And it's helpful to use an analogy of water to help us remember the words. I've drawn a crude water system here where you can think of water filling up a storage tank, and what we know about water is the deeper it gets, the greater the pressure there is. That's how dams work, for example. So pressure at the bottom of that tank makes water flow through the pipe, and it comes over here and does some work. And then, just to make it more like an electrical circuit, I drew a return path. So to help us think about vocabulary, current is like water flowing through this pipe, or like current flowing in a river. And voltage is like the pressure that pushes that current through the pipe. Electricity is not fluid. This is just an analogy, but it might help you to remember which word means what. So voltage is analogous to pressure. Voltage is like electrical, quote, pressure. It's potential difference in energy between 2 points, and it's that electrical pressure that makes current flow. And we measure voltage in volts. You will hear some people use other words to talk about voltage. The two, and here AKA means also known as. So the two words you'll hear people use when talking about voltage are first potential. Electricians will talk about potential, and that's because voltage is a difference in potential energy. And you will also hear some electricians use the term EMF, which stands for electromotive force. Well, this is an old-timey word. Electricity is not force, so this is misleading. Nevertheless, back in the 19th century, people used that word, and so you'll run into that. But we will call it voltage, and we will measure it in volts. It's interesting that in many systems throughout the world, it's a difference in energy that makes things move. So in plumbing and hydraulic systems, it's a difference in pressure that makes fluid flow. In electrical systems, it's a difference in voltage that makes current flow. And current is the rate of flow. Think of the current in a river. That's what I think of. So current is flow, and the measure of current is the ampere. We always call it amp for short. So amps are a measure of the rate of flow, how much electrical charge is flowing through our wire. So electricity is the movement of electrical charge as those little electrons are getting bumped loose and flowing. Current is the flow, and it's measured in amps. Voltage is like pressure pushing those electrons, and it's measured in volts. One more term is power, and it's measured in watts. And power is the rate at which you do work. We can also measure power in horsepower, so either horsepower or watts. When we're talking about, let's say, electric motors, we rate them in horsepower. When we're talking about our electrical systems in our houses, we measure that in watts. And just to clarify, a watt is a rate. So you can't say, when you're talking about a power plant, you can't say how many watts it produced, because a watt is a rate. It's like saying gallons per minute. The quantity is already built into that word. So when you say watts, or when you say kilowatts, which is 1,000 watts, you are talking about the rate at which that power is produced. If you want to talk about how much power, or how much was produced, or how much did you use in your house, you say kilowatt hours or watt hours. That's the quantity. There you go.